let us solve some numerical problems which are very important for your long answer type questions. So, before solving this long answer type question, everyone must have code book, that is IS 800 2007, along with your steel table book, and your calci, that is calculator. So, without code book, steel table book and calculator, we can't solve this design of fillet welds. Not only design of fillet welds, in design of steel structures, everything you have to design. So, we come across so many problems in further session. So, please get your IS 800 2007 code book and along with your steel table book. Steel table book and IS 800 2007 is very important to solve all the problems in upcoming sessions. So, please get ready with these three things, then only we can easily solve all the numerical problems. Is it clear? So, now let us see model number 1. We are having a plate is placed or overlapped on another plate in this way, and welding is done from here to here, here to here, here to here, and this length is L1, this length is L2, this length is L3 from here to here. Welding is done here, 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 from here to here. So, this is called S, size of the weld. This is S, size of the weld. So, what we have to find here? So, we have to find design strength in the weld. Design strength in the weld is how much? So, our main aim is to find the design strength in the weld. So, how to solve this problem? So, let us solve. Step 1, we have to write the given data. We have to write all the stuff that is given in the question. The step 1 is we have to write the given data. Step 2, that is size of the weld. Denoted with S, must be greater than or equal to 3 mm. Step 3, find the effective length. Have to find the effective length. So, in this particular case, the effective length is equal to total length. L effective is equal to total length of the weld. Total length of the weld. That is, so what is the total length of the weld? L1 plus L2 plus L3 is called total length of the weld. So, L effective is equal to L1 plus L2 plus L3. Now, step 4. Step 4, ultimate shear stress. It is denoted with FU. Units are Newton per mm square or Newton per meter square. It will be given in the question itself. Step 5, we have to find design stress. It is denoted with FWD. So, FW suffix D is equal to FU by under root 3 into partial safety factor. So, what is FU here? FU is nothing but the ultimate shear stress which will be given in the question itself. What is partial safety factor? Gamma. For your weld, it is different. For shop weld, it is different. For side weld, it is different. In order to understand the concept of partial safety factor, already given in unit 1 about partial safety factor. Please watch my unit 1 about partial safety factor. The last step is, last step 6 is design strength in the weld. That is P suffix D is how much? We are having the formula P suffix D is equal to 0.7 into size of the weld into L effective length into FWD, that is nothing but design stress in the weld. So, this is the formula to find the design strength in the weld. In case if this type of problem is given in exam, so first you have to check what sort of welding is done here. You have to do step 1, given data. Next step 2, you have to check whether the size of the weld is greater than 3 mm or not. Step 3, we have to find the effective length. What is effective length? In this particular case, effective length is equal to total length. What is total length? Sum of all the sides of the weld. That is, in this case, L1 plus L2 plus L3. Step 4, ultimate shear stress. Units are Newton per mm square or Newton per meter square. This ultimate shear stress will be given in the question itself. Step 5, we have to find the design stress in the weld. That is, F suffix WD is equal to Fu by under root 3 into partial safety factor. The last step is design strength in the weld. P suffix D is equal to 0.7 into size of the weld into L effective into FWD. FWD is nothing but design stress in the weld. The units for strength is kilonewtons or newtons. For stress, units are Newton per mm square or meter square. We have to follow these types of steps in order to solve this type of problems.